Hi, today we'll be solving this Leetcode problem, which is pyramid transition matrix. So here we are given the input as a bottom string and some allowed strings. In the allowed string, we'll be making a triangular bricks. Like first two characters will be the base, and the second, like third character will be at the top. So with those triangular bricks, we'll be forming up this complete triangular pattern. So if this pattern gets completed, we'll be returning true. Otherwise, it will be a false result. Okay. So how will we proceed with this? I'll take you to my notes. So as you see, for the first input, we have BCD, this as bottom string, and we had these allowed strings, and we are to form we are to complete this triangular pattern so that the topmost brick is having a single brick using these allowed triangles. So if you see BCC, this fits in here, CDE, this fits in here, and then we get the next layer as CE, and we find CE here. So this one, this fits at the top, and we complete this triangle. Now if we go to the next input, we have these sets of allowed strings, and here we will see the backtracking exactly. So if we we have to we can take multiple of these bricks. So if we take double A and B, we'll be forming these, and again if we take the same, so we'll be forming these, and again we take the same triangle, we'll be forming these, and then thereafter we'll be having the upper layer as triple B. Now using triple B, we'll be only getting E at the top, so the next layer will be double E. Now for double E, we don't have any base as double E. Like base is double A, so BC, double B, and DE. So this is not the correct solution. It will return a false. Now if we choose, so this kind of combination we'll be doing, and if we get to the top, then we'll return the true, otherwise it will be a false. So how to deal with this? Uh, First, I'll walk you through from brute force to the optimized solution. So what we will do is we'll iterate in the bottom string uh, from each index, and we'll check if the base in the allowed character is present. If it is present, then we'll be forming a next layer, taking the topmost of the chosen uh, string, and we'll be appending it to the layer. In this way, we'll be forming the next layer, and if we'll see if the next layer is possible or not. If it is possible, then we'll keep on doing it, and we'll reach to the topmost brick, topmost character. If it is feasible, then we'll return true. Otherwise, it will be a false. Yes. So in between, there will be cases wherein we would need to backtrack. So we'll be iterating. Let's add this index. We'll choose this one. We'll choose this one, and we take it, and we append this in our layer string. Okay, so we'll be having layer string as B. Now we'll go to this index, and we'll take again this, and the layer string will be double B. We take again this one, and the layer string will be triple B. In brute force, we'll be iterating each index in bottom string and form a correct next layer. Once layer is complete, we'll be assigning the bottom as the layer, and we'll be resetting layer to an empty string, and we'll write a base case accordingly. Like if the layer size is equal to 1, means we know that it reached at the top, so we'll be returning 2. Otherwise, if the layer size is equal to bottom size minus 1, so the next layer will be 1 minus of whatever layer we are in. So we'll proceed to the next layer then. So proceeding is like this one. So this is how we are going to code it. We'll create a helper function which will be having the bottom string, empty string, which will be showing as a layer, and the zeroth index in the bottom string, and the allowed strings. So if the bottom size equal to 1, we'll be returning 2 because we are at the top end. And if the layer size equal to bottom size minus 1, then we have reached to the end of the next layer. So we'll reset the layer, we'll assign the layer to the bottom, we'll reset the layer, we'll reset the index for the next for the bottom. So we'll iterate again for that layer. Now here in the allowed strings, we'll be we'll be iterating to each of the strings, and we'll match if the base matches with the uh, bottom indexes. So bottom like index and bottom index plus one. If it is equal, then we'll push uh, the top character which we have chosen to the layer, and we'll again explore further. And if we find if it hits the true case, if it gets completed, it will return a true. So if it returns a true, then we'll return the true. Otherwise, we'll keep on doing this. We'll backtrack it and then keep on doing this. One thing with this solution is that it's looking at the all allowed strings that are there. So the solution right now is giving TLE. So how to optimize is this? Right now, this is looking into all the strings that are there in the allowed uh, vector. So what we can do is we can make a constant time lookup. So if we use a map, then we can do the constant time lookup. What we can do is we can create a map in the starting itself, which will be having the key, which will be having key as the first two characters in the string, which will be so if the allowed, this is ABC, BCD, like that. So the key will be AB, first two characters, and the value will be the next one. So this will be using in like using to append into the layer. Now this reduces the lookup to constant time rather than looking it into everything. So the code is, so here in the starting itself we will be forming this map which will be having the key and the value associated with it, so that we can do a constant time lookup. Now in the helper function we are doing just we have added just this line. So if the key is not present in the map, we'll be returning false. So this way it won't do the ON lookup in the whole allowed vector. Here itself it will return. And if the key is present, what it will do is it will push back into the layer and it will go to the next index in that current bottom. It will keep on doing. It will backtrack. This is the optimization with the hash map. But this again gives the TLE. So further optimization that we can do is, why TLE it's giving is because it might happen that for a layer at one time we have already gotten a solution, like that layer is not solvable further, so it will return a false. But when we are doing a backtracking, and again we got the same layer, and we'll be then again calculating the solution for it. And it might happen that that solution that so what we will do is we will store that calculated solution into the into some sort of vector. And once if we again see the same layer, then that's pre-calculated, then we'll return at that time itself, and we won't recalculate again and again. So this optimize can be done. So here is the solution for aiding the memorization in this code. So what we have done is whole thing is same. We have initialized the map, and then we are calling this helper function with index 0, and then we have reached it off, then we'll return true. If the layer size is, so if a layer is complete and we have to move to the next layer, what we'll do is we'll store the result into the DP layer and we'll return it. And if the layer is already present and we have the pre-calculated solution for that, then we are not going to again do the same thing uh, repeated. We will be returning the result of the pre-calculated subset to this. So we are returning the DP areas, and this solution passes. So yeah, that is it. I'll see you in the next video.